move along to slide number 10. All right, so slide number 10 says, determine if f satisfies the conditions of the mean value theorem. If so, find all possible values of c. So what does it mean to satisfy the conditions of the mean value theorem? Well, the conditions are continuous on the closed interval a to b and differentiable on the open interval a to b. So what we need to do is we need to determine whether or not our function is continuous on, well, -3 to 2 and differentiable upon -3 to 2. All right, so first of all, x cubed minus 3x plus 5. This is a cubic polynomial, right? Any polynomial, you should know, is continuous for all real numbers and differentiable for all real numbers. So this is an easy one, of course. It is going to be a function where the mean value theorem is satisfied. So we can move right along to finding the derivative. So f prime of c. All right, so that one's pretty easy, 3x squared minus 3. All right, now remember, the conditions of the mean value theorem are met. So if that is true, then there must be a value of c in between -3 and 2, where f prime of c is equal to f of b minus f of a over b minus a. Now in this case, a and b, well, a is -3, b is 2. So f prime of c, so that means 3c squared minus 3 must be equal to f of b, so f of 2, minus f of a, which is -3, over 2 minus -3. Now, as some work on the side, f of 2. Well, f of 2 is 2 cubed minus 3 times 2 plus 5, right? So 8 minus 6 is 2 plus 5 is 7. So I get 7 minus. All right, then I have to find f of -3. So what is that? -3 cubed minus 3 times -3 plus 5. So -3 cubed is -27 plus 9 plus 5. -27 plus 9 is -18 plus 5 is -13. So I get 7 minus -13 over 2 plus 3, so 5. So 20 over 5, which is 4. So I am trying to determine when 3c squared minus 3 is equal to 4. So 3c squared equals 7. So c squared equals 7/3. So c equals plus or minus the square root of 7/3. Now, the mean value theorem said there must be at least one c. In this case, we get two answers. So you want to make sure that both of those answers are contained in the interval -3 to 2. So 7/3, remember 7/3 is 2 1/3, so the square root of 7/3 would be less than 2 because the square root of 4 is 2, of course. So that means that plus or minus square root of 7/3 is between -3 and 2, or both of those are. So we get two answers there. All right, moving on to slide number 10, or sorry, slide number 11. All right, so slide 11, okay, it says, once again, same directions. So f of x equals 3 times x to the 1/2 plus 2. Now, before I do anything, I want to consider the fact that this is 3 times the square root of x plus 2. So when I look at this function, what is the domain? Well, anytime I have an even root, I need to remember that the underneath the radical needs to be greater than or equal to 0. So the domain is x must be greater than or equal to 0, but the given domain of this function is -4 to 1. So what can we say? Well, f is not continuous on the closed interval -4 to 1. Therefore, f does not does not satisfy the conditions of the mean value theorem. So you're done. Now, let's say that you didn't realize this and you found the derivative anyway, right? So you would get 3/2 x to the -1/2, right? Or 3 over 2 root x. Now, when you get this derivative, you should once again realize, well, now I have an x in the denominator. So x now cannot even be equal to 0. Earlier, it had to be greater than or equal to 0. Now it can't even be equal to 0. So once again, you would be able to say that f is not differentiable at 0, and, well, still then doesn't satisfy the conditions of the mean value theorem. So it's important that when you have a function, you make sure you consider its domain initially, and then you find the derivative and consider the new restrictions from the domain for the derivative. All right, so now our last example, slide number 12. All right, once again, we go back to kind of an easy example. F of x is 3x squared plus 2x minus 7. So 3x squared plus 2x minus 7, of course, that's just a parabola or a polynomial, and so it is going to be continuous and differentiable everywhere. So we know that the conditions for the mean value theorem are satisfied, so then we can continue on to find the derivative. All right, so f prime of x, 3x squared plus 2x minus 7. So its derivative would be 6x plus 2, right? So now, once again, remember that the conditions of the mean value theorem are met, so that means that f prime of c will be equal to f of b minus f of a over b minus a, right? So f prime of c, that would be 6c plus 2, needs to be equal to f of b, so f of 1 minus f of negative 2 over 1 minus negative 2. So on the side, what is f of 1? All right, so f of 1, 3 times 1 squared plus 2 times 1 minus 7. So 3 plus 2 minus 7, so I get negative 2. So negative 2 minus f of negative 2. So now f of negative 2. So that would be 3 times negative 2 squared plus 2 times negative 2 minus 7. So 3 times negative 2, 3 times 4, that would be 12 minus 4 minus 7, right? So 12 minus 4 is 8. 8 minus 7 is 1. So negative 2 minus 1 over 1 plus 2 is 3. So I get negative 3 over 3, or negative 1. So 6c plus 2 is equal to negative 1. So subtract 2, so 6c is negative 3. So c is negative 3 over 6, or negative 1 half. So c equals negative 1 half. So that means the slope of the tangent at x equals negative 1 half is equal to the slope of the secant from negative 2 to 1. Now, one thing that some people forget about. We said there must be at least one c between negative 2 and 1. Now, what if you did this work and you didn't get negative 1 half? What if you got like negative 3? Notice, negative 3 is not between negative 2 and 1. So what would you do? Would you say there is no solution, or would you go back and check your work? So you should say that you must have made a mistake, because the mean value theorem says there must be at least one value in between negative 2 and 1. So if you happen to get two answers, like, for instance, on the first problem, we got two answers, positive square root of 7/3 and negative square root of 7/3. If one of those was not in the interval, that's fine. You would just rule that out. But one of them must be in the interval. So remember, you always have to have at least one answer on the interval. So that concludes the notes for today. Remember, your homework is section 4.2, 1 through 8. Hopefully you can do those. And McLaren, hopefully you're paying attention.